This is my lovely colleague, Baruch.
And this is Jessica Dean, the one and only.
Who
attended tons of previous sessions by Jessica Dean? You see all your finances here.
Perfect.
Good. Yes.
So today's agenda, so by the way, I'm a developer advocate for Azure for Microsoft. I primarily focus on Linux, open source, DevOps, containers, pretty much a lot of technology that's not directly Microsoft related, but that's open source that we have a heavy hand in. And this is Baruch.
And I'm developer advocate with JFrog, and since we are not yet as big as Microsoft, I'm just the developer advocate of JFrog. So our Twitters are right here. It's GLDean for Jessica, JBaruch for me. As you noticed in the previous couple of minutes, we are extremely entertaining, so you should follow us right now. Probably all follow Jessica by now, so it's just me. Well, I know that you don't have any energy to take picture of the slides or anything. The good news are you don't really need. We did all the work for you. You go to jeffrog.com/shownotes. That's the only URL you need to remember. And there you'll find a page for this talk, and it already includes the slides. It already includes all the links that we're going to talk about, and all the useful materials. The video I will add as soon as it is up, hopefully today, tomorrow.
Tomorrow, depending on when they get it. But as I understand it, the videos have been posted pretty quickly.
Yeah.
And here's this guy in the front like,
And
you know what he's watching on the plane? Every single session of Ignite again.
Right, and if you are not convinced, you should follow us on Twitter like by now. Conveniently, our Twitter handles are on every slide. So whenever you decide, yes, those guys are awesome, you just go and follow us.
Particularly if you do follow me online and you've seen Croc Hunter, by the time Croc Hunter comes on the screen, you're going to want to start tweeting that.
Exactly.
We have some fun stuff planned.
All right.
So we're going to dive right in. And if you've seen some of my other slides before or some of my other talks, some of these slides might look familiar. But I promise you the content and the demos are going to be different. But to level set the playing field, we have to first talk about the state of our industry, the state of this transitionary period we are in as a technical set of people. So we are going digital, or some might say that we have gone digital.
And my favorite banality of the last couple of years is every software is a software company. Every company is a software company. Gee, that's too early.
Such a tongue twister. But it's estimated that by 2020, 1 million devices per hour will be coming online. 1 million devices, 2020. That's less than a year and a half away. By that same year, the average age of an S&P 500 corporation will be 12 years of age. Compare that to the 1960s, where the average age was 60 years old. Right? Companies are getting younger, more and more are spinning up faster. We have more and more devices coming online. There's this rapid growth and this rapid shift. And the final statistic I always think is a little bit low. It actually should be, I think, a little bit higher. But they also estimated, and this was a study done by Gartner and Business Review, by the way, that 60% of computing would be done in the public cloud by 2025. And I think it's probably closer to 70, maybe closer to 75. But that's less than, 7 years away?
Yep.
I mean, we don't realize how fast we're kind of shifting into this more like ubiquitous era. We're no longer in the virtual machine era. So that's why we're going to talk very heavily about containers and tooling, how to manage it, how to kind of wrap your brain around it.
So this talk is basically about your future.
Everyone's future. And that's the point of it, is so if you touch software, if you write software, if you build the infrastructure software runs on, if you do anything with software, this talk is for you. And the first place to start is what we hear from our people. So we're going to start with developers. And yes, I realize we're at Ignite. A lot of you might be more ops. We'll get our moment too. My background's more IT. But if this sounds familiar to anyone in the room, these are our pain points. These are problems we have to address with this rapid growth.
And here is an interesting discussion about the developers part of DevOps, right? So let's do the poll.
Okay.
Who are here from the dev part of the house? Let's call it that way.
Awesome.
All right. And from ops?
It's like equally balanced.
Yeah. And who is not playing this game anymore? It's all DevOps?
Well, here's a better question. Who wears whatever hat your boss tells you to wear? Everyone's hand should go up. Otherwise, I'm talking to your boss. But So from developers, pretty much what we hear is that I need IT to not be the bottleneck, right? I have to create my applications. I have to be able to go at this competitive rate without worrying about IT or having to stop because they won't give me a system to work on. On top of that, when I do give you my software, now everything's broken because it worked on my system and your servers are the ones with the problem.
So here's a question, and we have here like a perfect combo. I'm more of a dev background, you're more of an ops background. So I clearly understand, and we'll get to it on the next slide, why you care about DevOps. And developers, so this is nice, but frankly, I could argue that I don't really care. New applications run smoothly on my machine. That's good enough for me. Now it's your problem, right?
Well, I guess it's my problem until then now I can't push the software update to our customers because we're going to get to the definition of DevOps, which then becomes important for both developers and operations, right? We both care about the same thing at the end of the day.
Okay.
Delivering value, and we'll talk about that.
Let's see if I'm convinced that I need DevOps by the end of this talk.
All right. So from the IT perspective, right, from all the ops in the room, I want to say about 60%, so we're winning right now.
All right.
I need to manage server compliance and maintain compliance with my corporate policy with little disruption. I can't just let developers who don't know anything about infrastructure go wild on my network. But you're right, I'm not a developer, so I'm unsure of how to integrate unfamiliar applications in my environment, so I have to work with you. We have to work together.
Yes.
And I need to focus on both server protection, security compliance, application compliance, all of these things from outside just a corporate policy perspective, right? So that's where it comes down into from both your stress points and my stress points, they're all the same. When you look at it from a fundamental level, we all have security threats. We all have to worry about efficiency. And we all have to support this innovation that we just defined, that we just went over. So we're now starting to be on the same page.
Yep.
But that's why cloud is so important. That's why containers comes in. Because we have this old school traditional model that everyone knows, virtual machines, traditional infrastructure, hardware is purpose-built. Everything was built for a project, for a distinct reason. But the cloud model kind of sets up the conversation for containers. It enables loosely coupled apps and microservices. It's now industry standard hardware. Processes and configurations are standardized. And your teams to deliver a service, which that's the ultimate goal, are DevOps-focused teams. So we have developers and operations working together to deliver a service.
And then, obviously, going back to the point why the developers actually care and need, one of the things, so for the IT folks, for the ops part of the house, DevOps have much more tangible interest, right? Because in the end of the day, DevOps helps the ops to push the software faster, better, more reliably, etc. And when we come back to the question why the developers need it, because I'm done my coding, now it's your problem, what actually helps is this feedback loop and this feeling of achievement. Not only I wrote my software and now I don't care about it, it will be up in 2 months or won't be up for never, I don't care. If I can see that my software is up and running in minutes and actually helps my customers and my users, that's something that suddenly I do care about and I want to help. And this short feedback loop and cloud microservices and containers actually help to engage the dev part of the house to be more involved in DevOps.
Exactly, and that's where DevOps really starts, right? It's a 3-stage conversation. It has the people that we just identified, and then we have to deal with process, which we'll go over, and then the products. Which products do I use? Which tooling do I use to handle? I mean, everyone's talking about Kubernetes, Helm, Draft, container orchestration, so many buzzwords. I mean, I think I could say DevOps, Linux, open source, like just keep going. Did I hit them all? So where do I start? So this is the ultimate reason why both Baruch and I, from whatever our backgrounds are, care about DevOps, and everyone in this room should too. So DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word in that definition is value. If we're not delivering value, what are we doing? What's the point of our software?
And this is interesting and kind of non-orthodox view on DevOps, because even from the name, you can guess that we are talking about other things. You are talking about dev and ops and QA and security, and it's not that clear how it actually translates to people, process, and tools.
And that's where we'll talk about that today. So the reason why I also always set the stage with DevOps and DevOps practices is because you'll hear a lot of these practices actually in the container world, in the Kubernetes world, in the tooling world. Helm, for example, which is one of the tools we're going to deep dive into, was built trying to utilize a bunch of these practices to simplify a bunch of them.
That's a wrong title. It should be DevOps Bullshit Bingo.
That would be awesome. Now we should write that session, though. I guess that would be this. So DevOps practices, infrastructure as code. You might also hear pipeline as code. So that's one you'll see today. Continuous integration, continuous deployment, that's your build and release. Automated testing, release management, monitoring. If you can't monitor your metrics, how do you know if you're delivering value? You need your telemetry. Availability monitoring. Do you have insight into your infrastructure? That includes your containers, your nodes. Do you know what's going on in your cluster?
There is a lot of going on in your cluster.
Yes, and that's where we'll talk about some of the tooling you can use. Sorry, we'll go back one just real quick. Load testing and autoscale, and then automated recovery and rollback. There's certain tools you can use that will enable you to quickly roll back in the event of a failure, and then be able to simply roll forward as you're pushing out new software updates, as you said, daily.
Yep, no, more frequently than daily. Daily, it's not.
Hourly.
Yeah, in minutes.
We're going to push a software update today in 30 seconds.
There you go.
So,
there you go.
Benefits of implementing DevOps, obviously, as we just alluded to, you're able to deploy code significantly faster. Your lead time for changes increases. Your mean time to recover increases. And your change failure rate decreases. And by the way, this is a study that's done every year by Puppet Labs. I only had, at the time of creation of the slide, was 2015, 16, and 17. But the 2018 report did just hit. And the reason why some of the numbers kind of change is you have to remember everything's relative from year over year.
And there is another interesting report that probably should put on another slide, is the DevOps Acceleration, DORA, DevOps Acceleration Report, I guess, by the same great scientist that actually started the Puppet Labs report, Dr. Nicole Forsman. And it's kind of similar, but it has another very interesting aspect there, and that's the code quality. One of the main reasons we hear for people releasing less frequently is we need more time for testing. And that's an interesting theory that actually makes sense. That's a hypothesis that's worth checking. And the DORA report actually checks it. They have this correlation or lack of correlation or reverse correlation between the release cadency and quality. And what we learn from this report is that not only the inverse correlation does not exist, it is a direct correlation between quality and the deployment frequency. The more frequent you deploy, the higher your quality is, and not the other way around.
And then there's also tools we can use to ensure the quality and security of our code as well, and we'll talk about that.
Exactly.
And that's where containers kind of really comes in, is how does it address and how does it fix all these other problems? How does it utilize these practices? Well, for developers, it enables this write once, run anywhere ability. It enables microservice architecture. So it's great for dev, test, and service deployments. He can write an application, he can bundle it up in a container, hand it off to me. I can put it on my computer or any cloud, and it's going to run the same way. So it gives me production realism. From an operations perspective, it's portable, as I just mentioned. I can take it, it's immutable, I can put it wherever I want. My environments now, whether it's dev, QA, and prod, are all standardized. And then I'm able to abstract the differences in my operating system distributions. Everything kind of becomes just a layer and different things that I can change very simply.
There obviously are challenges, and we are going to talk about that. And while Docker and containers in generally completely revolutionized the way we think about all IT, all software engineering, there are some interesting aspects of containers and Docker that we need to address, and we will do it. We will do it later. So it's not everything ideal, perfect, and easy.
There's certain changes that you have to make, and that's why it's called master tooling, right?
Exactly. But the change is here. We already in the middle of it, and there is no going back.
Yes.
Today, you cannot allow yourself to say, well, I'm not sure if I'm into this Docker thing. It's probably a hype. It will go away, and we will get back to the old ways. Not going to happen.
There's another statistic. I can't remember the company that wrote it. I think it was Gartner that released it. But it was also estimated that by 2020, over 50% of the applications running on the internet would be running in containers.
And I would say that's kind of low.
From a low perspective.
Yeah.
So this is just the direction. But that really sets the stage for what is a container. Everyone keeps talking about it. It's not exactly something that's tangible. So first off, it's not actually a real thing, okay? It's an application delivery mechanism with process isolation. And if you come from the Microsoft background, being at a Microsoft conference, it's actually built on several key Linux kernel features. So you'll hear things like namespaces, right? That's what a process can see. Or you'll see things like C groups, which is what a process can use. And we'll talk specifically about how that plays down into your deployment when it comes down to Kubernetes or Helm. C groups, for example, with memory and CPU. If you are using containers and you are using Kubernetes and you're already trying to master these deployments, are you setting resource requests? Are you setting limits? Are you defining what your pod is even allowed to have? And if you're not, we need to change that. So now what is Docker? We keep talking about Kubernetes and containers and all these other things. How does Docker actually fit into the story? So first off, from a very basic level, Docker is an open source container runtime. It has Mac, Linux, and Windows support. It's a command line tool. It uses the Docker file format. That's the standard format most people use with Kubernetes, though Kubernetes does support a secondary format. I don't know anyone who uses it. And then the Docker image format uses a layered file system. That's what we talked about earlier. So that looks like this.
Yeah, there is a company, Docker, also, but they're much less interesting than the technology.
Yes. So Docker also had their own container orchestration, but at this point, I think everyone's gone all in on Kubernetes. Mainly for scheduling, for a bunch of different features that we'll go over.
Yeah, so when you hear about Docker, it will probably be the container technology, then the company, and actually, it's now so common and so commoditized that actually you will hear containers much more frequently than you will hear actually Docker. But at the moment, at least, from a standard de facto perspective, they are the same thing. Yes. There are no other container technology.
You use the Docker image or the Docker file to build your image and then run your container. And this is what a layers looks like, right? So, and we'll see another slide on the second one of actually my Croc Hunter demo of how that actually looks in real time. But you have individual layers that are built up in your image, and then your read writes actually happen on top of the image itself once it's in a container.
So this layer, those boxes that you see here, is actually, if you simplify it a little bit, is just an archive of something that changed in the file system because of a command that you wrote in your Docker file. So every command in a Docker file obviously affects something in the physical world of a file system, and this change is encapsulated in what we call a Docker layer.
And this is a better visualization of this, because this is actually a real-time Croc Hunter. This is my demo that we're going to see today. But for each one of the things that I could change the label, I could change the expose port, the command, environment variables, anything. Each one of that gets cached as a layer. That's why actually somebody had tweeted me and wanted to know, how do I do a git clone on a private GitHub repo in my Docker container? How do I do that safely and securely? Do I use an SSH key or a personal access token? Do I use multi-stage builds, which is where you define one part of your Docker build, so to speak, as build, and then the second one as publish or run? And that, by the way, would be the correct answer. I have a whole blog post on that. But the reason why is if I put anything that's secure, a password, a variable, an SSH key, a personal access token, in any one of these layers, and I just let it build all the way through, even if I put another command to remove that variable, it's still baked in one of the layers. It's still cached, and therefore is unsecure.
Because adding this environment variable or the way you express this key actually changed something on the file system, and this change was encapsulated in a layer, so it's there. Now, if you delete it, it will be another change that will create another layer on top of that, but both of those changes will exist as layers in your Docker image.
Yep. And now, how does containerization differ from virtualization? Two different types of virtualization, of course. You have your hypervisor sitting directly on top of your hardware. You have a host operating system sitting on top of your hardware, and then your hypervisor sits on top of that. In both scenarios, you have a virtual machine running an operating system, dependencies, application. We all know that. Containers is a little different. You have your hardware, you have a host OS. You actually have a Docker engine that kind of sits beneath that, and then your container can run on top of that. And even Kubernetes will end up using a Docker engine as the underlying layer for its orchestration.
And technical people will love to be very precise with our definitions, and we run around shouting that containerization is not virtualization and they cannot be compared and everything. But when it really comes down to the usage of it or the thing how you think about it in a very abstract way, I think it won't be that huge of a sin to see containerization as a very, very light version of virtualization.
It's operating system virtualization.
I will be
shot
shot for that by someone because I said that, but I truly believe that from a perspective of concept, it's not that different.
Yeah, one's hardware, one's focusing more on the operating system and the kernel. So advantages of using containers, and that's what we'll dive into today when we start talking about tooling. We have to know, why do we even care? Why are we using containers? First off, for the developers, for the pain points we talked about earlier, it enables fast iteration. We can now have agile delivery and immutability as we identified. For IT, there's now cost savings, right? I'm not spinning up 1,000 virtual machines just to run 1,000 applications individually. I can have 1,000 containers or pods or deployments. Now I can have a more efficient deployment. Everything's also defined as code, especially when you're using your Kubernetes YAML files. For those who don't know, Kubernetes YAML files, Kubernetes is a declarative deployment delivery system. So I write the world as I want it to be and push that out, and that's what deploys. And that's where Helm kind of comes in. I can know that that deployment is going to be efficient because everything is easily manageable. And then it's also elastic bursting. You can burst into other areas as need be.
And take a look at those central advantages for both parts. The agile delivery for developers and the efficient deployment for IT. Those are the same advantages we spoke about for DevOps, right? You remember we decided that the single biggest advantage of DevOps for developers is actually see what they did running in production and helping providing value. And for the IT is taking whatever the developers wrote and it actually works. That's the official deployment. So those are the same values that we spoke about in DevOps.
And it enables us to deliver value to our customers. So now we're going to go into a demo. This is where Croc Hunter happens, and we get to have a lot of fun. And thank you for bearing with us for looking at the PowerPoint for so long, because I know no one likes just staring at PowerPoint slides. So first off, we're going to go ahead and make this full screen. And yes, I do have, obviously, my epic Croc Hunter. It's coming live to Ignite. So I gave this demo last week, which is why it says Jenkins World, or Jenkins Edition. So I can shoot little butlers at crocodiles, and I can live out my dreams as hunting crocodiles as soon as one happens. There we go. Now I can.
Well, we are in Florida.
We are in, well, I'm not shooting alligators. But okay, so the one reason how come I really love this particular demo is, one, I can see a lot of really useful information. For one, I can see a commit ID, I can see the release name, and I can see the host name, which is the pod that this is running on. If I zoom out and I go over to my commits history, and I'll zoom in here real quick, we can see a few things. One, if I go back, that commit was F906 was the first 4. F906 was a previous version that I did last night, or technically very early this morning. So I also pushed another update because I do realize that we are at Ignite, and I mean, Jenkins and Butlers, as cool as they are, probably not the coolest. So I have a pipeline that I have set up. And by the way, the pipeline is already in my GitHub repo, which is on his show notes. So we can take a look at how that's
What is
structured
this?
later.
What are we looking at?
So right now we are looking at CodeFresh, which is a CI/CD tool, right? That's a continuous integration, continuous deployment tool or technology we talked about earlier. I set up a pipeline that defines.
You know what? Wait a second. Okay. That's a lot. Who knows what Jenkins is? Okay, all right. Who ever heard of CodeFresh? Yeah, no, we need to explain it a little bit more.
So who's heard of Azure DevOps? Okay, Travis CI, Circle CI. All right, getting less.
Drone.io. We can go the.
No, but my point is that all of them are CI/CD tools to help delivery. But how many tools do you know of focused just on Kubernetes deployments for CI/CD? Who knows of one?
Azure DevOps?
Azure DevOps is not focused just for Kubernetes. It's a platform and you can use it, but it's not tailored for one particular endpoint.
Okay, I tried.
CodeFresh is we're working on it. CodeFresh specifically is a tool that's designed to be just a Kubernetes pipeline. I can implement all my DevOps practices. I can define a full pipeline using Helm, using Kubernetes, using everything. But more importantly, as I'll show you, I can also have insight into my Kubernetes clusters, into my Helm deployments. I can easily roll forward, roll back. I can do everything I need to do for Kubernetes with this one particular tool. Or not necessarily one, we can expand it out and we'll show that. So right now I defined obviously a pipeline just as I would do in Jenkins or just as I would do in Azure DevOps. My pipeline is actually written in YAML. So if I scroll down here, we'll open this in a new file and you can kind of see there's actually a lot going on. I'm having it build a Docker image. I'm having it push it. I'm going to package up my Helm chart. I'm going to deploy with Helm, and we'll talk a little bit about Helm later on. We'll go into some live demos at the end. I'm going to deploy with Helm. I'm going to test to make sure everything works if it's on the dev branch. I set environment variables. But down here is where we start getting pretty cool. I'm actually doing some testing of my Docker image. I'm running some Selenium tests. Scrolling down even further, I am publishing my volumes. I'm pushing all this stuff up to registries, right? And I actually have a registry over in JFrog Artifactory, both for my Docker images and for my Helm chart. But what Artifactory is doing is it's linked over to JFrog X-Ray, and it's actually scanning my images and everything I push for vulnerabilities. So I'm having a bunch of scanning go on all simultaneously with this pipeline. And we can see right here, down at the bottom, if I zoom in here, you can see build and push information to Artifactory. I actually have in CodeFresh rich links back over to JFrog to see where all of this stuff is going.
We'll see it.
We'll go take a look at that.
Yep.
First, I want to show you, I'm going to go over to my Helm releases, which is over here under deploy.
Well, what is Helm? You mentioned
So Helm is the package manager. We're going to dive deeper into this. I like to sometimes do a cold open where I show you something that's awesome, and now you have to stay in the room because you have to learn what it is. But Helm itself is a package manager for Kubernetes. It allows you to take even your most complex workloads. If you have a deployment YAML, a service YAML, an ingress YAML, a persistent volume claim, you start having all these deployment files for your container deployments, and it helps you manage it very simply, and we'll show you how.
So that's kind of a next level of abstraction after Docker, when you take multiple Docker containers and manipulate them together.
Yes.
It's especially important with stuff like microservices, when you want to roll out your entire application, which consists of 40 microservices of different versions together, and you want to manipulate them together. And also it helps with a very popular design pattern in the containers world, sidecar, when you actually always deploy more than one container in a pod. It's very, very convenient to manipulate them together, and this is what Helm gives you.
Helm really kind of simplifies that. So actually you can see, since he talked about having more than one, I actually have 3 replicas running for Croc Hunter, which enables me to also have continuous kind of upgrades, right? If I push an upgrade, it's going to kill one container, it's going to spin up one new one, it's going to kill the other one, spin up another new one, until I have 3 of the new one. Also using Helm, I get things like history. So Helm uses things called charts, and I can actually see all of my charts, every upgrade that I did. And this doesn't just push one change to one file. It's I made a change to my ingress, or I made a change to my service, or to my deployment. I can manage that. So I made a rollback earlier this morning where I rolled back to my Jenkins World update. But I told you that I had done an update for Microsoft Ignite. So I'm going to roll back actually to my Microsoft Ignite one so you can see how awesome that is. And by me using CodeFresh, I can click this button off to the right, which is rolling back. It's literally a rollback button. But what that actually does is that issues a Helm rollback command. So you can run that command just as easily from your local system, or you can run it from any CI/CD tool that you want. CodeFresh just kind of makes it easy to understand with a visualization.
And this is, by the way, one of the important things about having your charts, having your containers, having your application around in kind of a composed format and not rebuilding every time from scratch, because this is what allows rollback, right? What we do now is we take the previous version of the Helm chart, which refers to previous versions of the Docker images, which are actually cached in our registry in JFrog Artifactory in this example, and just roll them back to production.
Mm-hmm. And now, so you can see something right here. I zoomed in on the left-hand side of deploy. I'm looking at Kubernetes. So I actually get insight into the services, namespaces, everything that's running in my Kubernetes cluster. And I know that I have this demo deployed out to my OzCon CodeFresh. And while he was talking, for anybody who could see, the replica number was actually changing. At one point, it said 2/4, right? Because it was spinning up another one for my new update. It was killing one of the other ones. And then it said 2/3. And now it says 3/3 because it updated. And I can see images. That's my old git commit SHA, but if I refresh this, that image number should change to where now it's the image tag or the, I guess the git commit SHA tag for the latest update, which will go view the application. But I want to show you how that changed right there, right? Now it's Charlie, 0, Frank, 4, David. So if I zoom out and I go back over to Croc Hunter and refresh, with that one button, I just rolled back to my previous version. And now, since I know everyone's so curious, what do I hunt crocodiles with this time on the Ignite version? That's right, Azure logos.
Right.
But this still isn't cool enough because that shows us how we can roll back. That doesn't show us what actually happens when it goes through the full pipeline and do a build. It's also not really fair to JFrog because we're talking about Azure, but we also haven't gotten to show some JFrog stuff.
We will. You already mentioned the importance of metadata when you spoke about the commits that we can look at, but the metadata that we kind of looked at now is very, I would say, scarce, right? You need to go and fish for it and find it in different places. So we will see now a little bit more streamlined version of working with metadata.
So first thing I'm going to do is I'm going to go ahead and fire off a build, and we're going to let that run in the background while Baruch goes through and shows you some of the images, some of the tests, everything we can find in Artifactory and X-Ray. While he does that, the build pipeline is going to go through. We could go take a look at it afterwards, but we're going to see a live update of what actually happens if I make a live code change to my Go file. And to show you, it's just a simple Go application. Here's my Docker file. I'm using my own image for my own version of Alpine Go, and Baruch will explain a little bit more about that because it's hosted in JFrog.
Yeah, I have a question. I love the polls, and we keep people a little bit
curious.
How many of you use Docker? Let's start with that. Okay, fair enough. How many of you who use Docker use latest in production? Okay, very good. Jessica, what's that? Why we have latest here?
I have latest because I'm using my own image, and it's also a latest that I've already approved the changes attached to a build ID. So when I went through my pipeline and I made through like building a new image and everything, pushing it, tagging it with build ID, before I could also add a tag of latest, I have to go through and approve, making sure it meets my company compliance and my patches.
Okay.
So for me, I'm safe to use latest.
This is a good latest. And this good latest means that it's our image.
It's also an image I control.
It's an image we control, and that means that we can safely say that whatever we have, and whatever we checked, and whatever we approved, all of them are good. Mm-hmm. And that means that I can safely use any of them, including latest. Now, it's actually very nice to have latest here, because for example, this is Alpine, this is Alpine. Great. Yesterday, new security vulnerability was found in Alpine. Do you know about that? Okay, now you know about that. And you want to run and change the version of your Alpine base image in all your Docker files? You want and you should, not in our case. Because in our case, all we need to do is upgrade the Alpine in our base image that we control, and then all the rest of our images that use the latest, our latest, as base will automatically be updated to the latest secure version of Alpine.
Because
Does that
we've
make sense?
approved it. And we're also able to confirm that because using X-ray, I can also scan all my images for those vulnerabilities.
Let's see, by the way, if it finds this Alpine vulnerability.
So I'm going to go ahead and push my change. Once I push it, we'll show CodeFresh on how it's actually going to kick off the pipeline. So I'll go over to builds, and I can see right here, it's starting off I'm going to zoom in here so you can see. It's starting off, it's going to clone my repo, it's going to build, it's going to push to Artifactory, it's going to do a bunch of stuff. And so I'm going to go over to my Artifactory screen. We'll go ahead and make sure I'm logged in here to, nope, X-ray. We'll first go over here to my Artifactory, and I will get X-ray. While he shows this, I'll get X-ray going on this other computer so we can keep the demo.
Okay, so here the interesting part is the integration, obviously. So I'm going to go here to CodeFresh and look at the previous build. Look at the previous build where we have the Ignite update. And we can look at the logs here to see what's going on. We have here this build step that actually pushes the Docker build that we build into Artifactory. And with that, after it actually did that, it has the next step of promotion here. The promote to Artifactory. And you can see here, successfully run push step promote into Artifactory. You can see here in the logs that the Docker image that we push actually goes to jfrog.jd, crochunter at jfrog.io, and that's exactly the Artifactory instance we saw here. And one of the interesting parts here, so obviously Artifactory is a universal artifact repository that works with any type of package manager or dependency manager that you care about. You can see here a list of what you can work with, and you can see here that we already start working with Docker and with Go and with Helm and with generic. So let's take a look at what it actually does. This is like a tree, and you can see here there are obviously a bunch of files. So in the Helm repository, you can see all the Helm charts, and this is kind of a very naive way to look at it. It has a very nice ability to filter and search whatever and ever, but instead we can only see, okay, now I want to only see Docker. And let's see if I can see all of them, or I can do this to see all of them. Here, those are all the Docker images that I have here, and this will be our croc hunter, and you can see the Docker images right here with all the history. You remember we saw the layers? Those are the layers right here. So we run some commands, we export some ports, we copy some files, etc. But the real interesting view that I want to talk about is the build view. And the build view here is really the next level of abstraction above looking at the artifacts themselves. Because this is what we spoke about. You have a lot of going on, and whatever going on is actually expressed in those builds, which is take a bunch of different technologies, run all of them, and eventually get your product. And this is what it gives you. It gives you a complete metadata over all of it. So we're going to look at Croc Hunter, and you can see here all the builds that we're running, and that would be the last build that we have. And you can see here that it captured the build information about the Docker image. Those are the SHA-2 checksums of the different layers that we produced. Those are this is our Docker image, this is our manifest, and we can go and look at it and see, oh, okay, this is my manifest right here, and those are, again, the Docker layers that we used, and you can see here the same commands. You see exactly the same, copy and everything and what's not. And the interesting part is that we always know how they were created. So if you look at any Docker image or any artifact on this, in this system, you can always know how it was built, how it was created in one form. You can go directly to the build results, and that will be back to our CI server to CodeFresh, and you can see how the build went, and you can dive into it and see, for example, dependencies here. So this is another artifact, and this is the Helm chart. And the Helm chart is actually the this archive of what we produced and deployed, and also other artifacts. So the artifact that Jessica just downloaded is actually test results. So if we can click on it, you can see here that we have the test results right here. We capture that as metadata and attached it to our build. So what it actually does, it provides you metadata for any step of the way. And it also knows about the relationship between the two. So we can see here that this Helm chart and those build images and those build results are a part of one thing. And talking about metadata, metadata doesn't stop there. It doesn't stop of knowing, okay, this artifact is related to this artifact. We actually care about other metadata as well. Do we have security vulnerabilities? Do we have any type of licenses which are a problem for us? And we can actually go to X-ray and see more metadata about our artifacts as well. So X-ray is a universal component analysis tool. It sits on top of Artifactory, and it realizes all the artifacts that we have there, not only for what they are, but also recursively going through the archives and discovering more and more of artifacts. And if you think about it, most of the artifacts that we deal with are actually archives. Helm charts, tar.gz. Docker image, bunch of layers which are archives. All the Java resources, they're all web archives, Java archives, and what's not. Go modules, it's an archive of Go sources. NPM applications, they're archives as well. And that means that we can go recursively. Debian, RPM, all of them are archives. We can go recursively and do that. So what we can see here, this is our build that we actually monitored. And we can take a look at that and see that, gee, that was a very, very bad build. Look at that. We have 2,184 pages of violations.
We can just scroll over. We can also see the severity.
Yeah, so let's look at the real bad ones. What is that? Whoa, what did I do? I did back. Okay, let's look at it again. Let's search. This is it. Let's look at the severity, and let's take a look at this one. So this is a vulnerability inside Debian operating system, which is a part of one of our layers, which is a part of one of our Docker images. And we can look at the component here, and this is a Docker image as a component, and see all the vulnerabilities inside it, and we can also see where it actually is. This Docker image is inside Docker production on our Artifactory server, and that actually looks bad. But
so let's go see our Croc Hunter one.
Yeah, let's go to the, let's see how bad the Croc Hunter is.
We can actually get to that right from our images over here, artifacts. And if I zoom out here real quick, should be able to go to our OSCON. I can see the summary. These are all the annotations that I push. So this was the most recent one for Croc Hunter build. I can click this rich link. It'll take me back over into X-Ray. And I can see so far, look at that, I don't have any violations.
All right, so we have...
It's like we planned it.
Yes, look at that, it's all green, amazing. So I wonder if we have the latest Alpine or your X-Ray database is not up to date.
Potentially. Potentially, I did not update the X-Ray database.
But you know what? Let's go with the theory that it is the latest.
That I'm just awesome.
Yes,
So,
and it is the patched Alpine.
And now we're going to have the final moment for JFrog. We're going to refresh this since our pipeline finished with the JFrog edition. And I'm going to go ahead and hit space, and now I'm using frogs, right? Perfect.
Okay, folks, you just saw how a sheep shoots frogs to hunt crocodiles.
We have to make sure we clarify that because, again, in Florida, alligators. But for those that were wondering, remember, we did a live change, right? So we did a live rollback. We did a live change. We can make all these iterations. And while he went through and talked about artifacting X-Ray, the entire deployment only took really, what, a full minute to do a full build. It took less than 30 seconds to roll back.
And that's what I talk about, like 1 minute.
Exactly. That's why we have these policies in place, and that's why we're using these tools. Now I'm going to switch back over to my slides, and we're going to go talk a little bit more about Helm and all these other charts and words you heard, and then we'll show you from a command line level how to start getting familiar with it, because you kind of have to use them first before you know how to plug them into your pipeline, right?
Yep.
But we wanted to show you that there's all these tools that have support from a DevOps perspective. So we'll go back over to the PowerPoint right here. We'll go ahead and play from the current slide, which should say demo as soon as that comes back up.
There we go.
All right.
So, kind of to wrap it all up, and you saw a lot of magic going on, just for you to make it clear what actually happened, right? So we wrote some code. And in this code, we added some, except of the new code that we wrote, we also added some dependencies to it. We used out of this huge list, we obviously used Docker, we used Helm, but also our application was actually written in Go and JavaScript, so we used Go and NPM, but you might use other resources as well. And all those dependencies, new dependencies, should actually come from somewhere. And in the example that we saw, they come from JFrog Artifactory. Obviously, there are other choices. And JFrog Artifactory can run both on-prem and on any cloud, including, obviously, Microsoft Azure. And the 60% that we spoke about that will run on the cloud will obviously use the cloud version, and the other 40, the on-prem. If the dependencies are already there, they will just be returned, and then local build of the developers will be successful. In other scenario, Artifactory will actually go to remote repositories or remote registries to find it. When we update our Alpine to the latest version to fight this security vulnerability that was discovered yesterday, it will actually go and fetch the new version of Alpine from Docker Hub. Once this is done, we have a new artifact in Artifactory that should be scanned with X-Ray, and that's what you saw. And X-Ray will keep updating its metadata, its list of vulnerabilities and versions and licenses from external data sources, whatever they are, and will scan those artifacts, and only after scanning, they will be returned to the machines of the developers who write code and use this new stuff. Once this is done, next step is obviously git push or whatever version control you use. And this is where our CI servers kick in. And we saw CodeFresh, but there are obviously other options, TFS, VSTS, the Travis, Drone, and Azure DevOps as of last week, and what's not, and Jenkins, coming from Jenkins world. Yep. Whatever it is you are using, it will actually do the exactly same thing. It will use the same build tools to run the same build that the developers run, but now kind of an integration with more testing, with other people's commit. And the real difference here that while in step 1, when we run a local build, what we did with the results? Nothing. We just run it to check that it actually works on my machine. But in the CI server, the results are everything. They are our product. This is what our company charges money or doesn't charge, but this is why our company exists. So this is crazy important to get those artifacts and to actually store them. And they are, resolve dependencies. And then the artifacts will be stored in Artifactory, which is a good start because now you can do this rollback that we just did from Conference. You remember we took the previous version that was stored in Artifactory and then boom, run it in production in 5 seconds. And if we did something wrong, the rollup was really quick. And this is what you need when you have frequent updates. Another important thing is this metadata that we spoke about. This is very, very important as well. And the metadata from the CI server is one of the most important parts because this is where your product is created. So all the information that we can get from there, which artifacts were produced, which dependencies were used, which environment variables were in fact running on the CI server agent or whatever it is, it's critical to capture all of that. And we do it using plugins that we provide in JFrog, or if you use some CI server, which we don't have a plugin, you can just use JFrog CLI to collect all this information and then deploy it with Artifact in what we call the build info bill of materials. It's an open standard JSON file, not YAML, that is deployed to Artifactory as well. And all those are getting scanned by bunch of, and now your pipeline actually starts. While you converted your sources to your artifacts, this is where your pipeline kicks in. And you do a bunch of stuff. You do test Selenium or penetration or performance or
Selenium, but yes.
Whatever. And you get all this information and you keep adding metadata on your artifacts. You tell more things about artifacts. Now you know that it works in Chrome and Firefox, and I usually have the joke that it doesn't work on Internet Explorer, but I think that's not the appropriate stage for making this joke.
I did my demo in Chrome, so.
Okay, maybe it doesn't work in Internet Explorer.
I also
we will never know.
Run Internet Explorer Mac.
Right, so you collect all this and you keep adding metadata, and it stands this load, and it whole bunch of stuff. And obviously the metadata from X-Ray, it doesn't have security vulnerabilities. It doesn't have any dependencies with non-compliant licenses. All that is added more and more to make a very, very important decision.
Yep.
Can it go to production or not?
Yep.
And if you decide it can, here you have a number of options. First of all, if you deploy it to servers that you control, either it is in your data center or public cloud or whatever it is, you use the tools like Chef and Puppet and Kubernetes and Docker and Helm and whatever you use to deploy to the servers that you control. Another type of software is distributable software. And that's software that people or machines or IoT devices download from the server to run on their premises. And then you have a number of options. You can use stuff like JFrog Bintray if you want to do public distribution, if people actually need to download your software from all over the world. Or if you have private distribution, if you have a company that has different development centers or operation centers or whatever other pieces that you need to push your information to, you can use another product of JFrog, JFrog Distribution, to do a private distribution to Artifactory edge servers.
Okay.
So this is kind of the big picture, and I hope it makes a little bit more clear what we try to do there. We run a lot of tools simultaneously. They all run fast and do a lot of stuff. And just to look at this promotion pipeline from another perspective, what you see here is this part of when we add metadata on every step and then promote artifacts between what is called quality gates. So you can see here how fast, right in the beginning of your pipeline, your sources become not irrelevant, but just another point of reference, and you actually start working with artifacts, and then you take those artifacts and you promote them through those logs, which are quality gates, Selenium checks, X-ray checks, performance checks. And if they are good, they're promoted to your next environment, which means you move the artifacts from one repository to another, and you deploy them from this repository to the right environment to continue testing them and promoting them further.
And so now, to simplify everything that Baruch just talked about from a whole up product suite for how they fit into the pipeline that we did, let's take it a little bit simpler to understand what truly happened in the demo, right?
So that's a use case that we used from the big picture.
Yes, this is just simplified, just down from the big picture. This is what we did today, where we have code living out on GitHub. This is code you can go out and use today. You'd have to update the image accordingly, of course, because it's in my private repo. But then I used CodeFresh for my Kubernetes pipeline. It handled everything. It handled my Docker build. It handled my Helm packagement, my Kubernetes running out on Azure, my Selenium tests. But then I had JFrog and Artifactory and X-Ray as my Kubernetes repository. That handled both my image repository and my Helm charts. And then X-Ray was scanning, of course, my images as well, ensuring that every part of it was clean and free of vulnerabilities.
So just to, the previous slide? Yep. Just to attach that to the previous diagram that you saw, that's exactly that, right? So we write some code, we commit it to GitHub, and then CodeFresh on the CI server kicks in. It runs the same build, it creates Docker image, it creates Helm charts, it uses Artifactory to pull the dependencies like the base image from, it uses Artifactory to store the artifacts and the build info, and then we start the promotion pipeline. So we add X-ray results, we add Selenium results, and then we actually deploy whatever we have to the servers that we control on Azure using Kubernetes and Helm.
Yes.
That's exactly what we saw, the whole picture, with this particular set of technologies, and obviously your set might vary.
And so now we're going to dive a little deeper into Kubernetes and what it is. So frankly, it's a container orchestrator. It's an open source container orchestrator. It was originally designed by Google. It's based on a system called Borg, and they use that to run billions of containers per week. Features that it includes might remind you of features that align with DevOps practices, right? You have things like self-healing and scaling. It also offers things like service discovery, load balancing. We can manage secrets so that way in my Kubernetes cluster, I have access to my private repo. There are over 2,300 contributors to the project, including Microsoft. And as of March of this year, it was the very first project to have graduated from the Cloud Native Cloud Foundation. More on that can be found online. Who's actually using Kubernetes? Like, is it ready for production? Great question. Also, if you work for any of these companies.
Who's using Kubernetes?
Awesome.
Okay.
Who wants to use Kubernetes, and that's why you're here? Awesome. Even more.
This is bad.
So if you've been hesitant to use it because you don't know if it's production ready, you don't know if it's real time, here's just a small list of some of the companies. You might not have heard of some of these, but I mean, small companies like eBay, GitHub, Reddit, more, Pokemon Go, SoundCloud, Ticketmaster. I mean, this is a production-ready tool. And that's where Azure Kubernetes Service comes in. So all the demos we were using, I have CodeFresh, I have JFrog, I'm running open source tools. It's all backed, every demo I do is using the Azure Kubernetes Service. It is your Kubernetes cluster, and it's managed by us. That means we take care of the control plane. So why do we recommend AKS? First off, it's the fastest path to Kubernetes on Azure. You can get up and running with 3 simple commands. I like to argue that's technically 2.5, and we'll show why. You have automated upgrades and patching. You can easily scale your cluster up and down. It's self-healing. Most importantly, it uses open APIs. It's 100% upstream, meaning there's no forks. It's not a Microsoft version. This is full-on Kubernetes.
And one thing to add on top of that is that the majority of you are not using Kubernetes right now, and you need to get started, and you will find Kubernetes overwhelming. You will, because it is. One of the most important tips that I can give you to start with Kubernetes is start with one of the clouds. And obviously, I can recommend Azure heartily. Others do something similar because it simplifies the complexity of Kubernetes to 2.5 commands that Jessica is going to show you. Even if the end goal is to run it on your own premises and not using the cloud. Start with the cloud, because otherwise the learning curve is just too steep.
There are ways you can simplify the on-prem learning curve, but I agree with Baruch, is you want to make sure that you get started and comfortable setting up your cluster with the cloud. For Azure, like I said, 3 simple commands. The first command creates your cluster. The second is that optional. That's that half command. If you already have the local command line tool, which is called kubectl, or kube control, depending on your pronunciation, if you already have it on your system, you don't have to run that again. And the third command will authenticate to your cluster. The second set of slides, or the second slide here, is actually managing. So it's how you interact with your cluster. I can list the clusters I have available. I can easily upgrade my Kubernetes version. I can scale my clusters out. When you play with stuff kind of on-prem, and I'm going to show you a demo today where I'm just going to do Kubernetes locally, I only have one node, one really cluster. It's not really full Kubernetes. I'm not understanding how scaling works or persistent volume claims or storage classes. I'm not diving deep enough into it.
How about logs? How about monitoring? How about observability? How about tons of different complicated stuff that you need to set up if you want to run it on-prem?
Exactly.
Really don't do that.
So,
at least not from the beginning.
Yep. And so without AKS, or without honestly, any managed form of Kubernetes, you're responsible for the control plane, which is your master VMs, all the hardware, all the software, everything, and your agent pool. But when you use a hosted source of Kubernetes, they take care of the control plane, in our case, Azure, and then you're just responsible for the agent pool. So now, how do we simplify this even more, right? Like, this is still very complex, as we've talked about. You heard me mention Helm. It probably still sounds very overwhelming. Who knows how to go write a Helm chart? I mean, there might be a handful of people in the room, but it can be very complicated. So there's quite a few release automation tools. Actually, all 4 of these tools up here are all open source, and Microsoft is all primary contributor to a bunch of them. Draft and Helm are the 2 primary ones we're going to go through today. And Helm, as we explained earlier, is the package manager for Kubernetes. It's the best way to find, share, and use software built for Kubernetes. You can manage complexity, as we talked about. I can easily update, as you saw. I can do rollback, and I can share. Even Baruch showed you where we had the tar file, right, in Artifactory. I can easily share and distribute that. This is a better visualization. I can tie in my database, my services, my CI, my load balancers, everything into a chart or a release that I can then use. And this week, one of the big announcements was that now you can also have Helm repos over in Azure, which I actually just played with the other night and is pretty awesome. So the other tool that simplifies this Helm even more is Draft. And this is the one demo that I want to show you today of how to quickly and easily get started with creating Helm charts. Is you can actually get started creating all this stuff, including Docker files, with 2 commands, draft create and draft up. And so using those 2 commands, developers or ops can start to kind of hack on container-based stuff without having to go out to the cloud, though we do recommend it. It is able to succeed based on language support. So Draft is able to detect the language that your app is written in, and then it uses packs to generate the Docker file and Helm chart that's built on best practices. So we'll see a demo of that right now. And then I'll show you kind of how easy it is when you do end up using Helm charts. So we'll end my PowerPoint here, get my mouse back. Great. So I'm going to go over to my terminal, and I'm going to zoom in here real quick. The first thing I'm going to do is I'm actually connected to a cloud cluster right now. So I'm going to change to bad Wi-Fi, which is my alias for local, in case the Wi-Fi at a convention sucks. I can cut my demo locally. And then I'm going to CD. Actually, I'll go over on this side of the screen, and we'll just move it over because I'm already in my directory. I'm in a draft examples directory, which draft is, I think it's Azure/draft on GitHub, but this is a directory I forked from them. So to show you all the languages right out of the box that we support right now, I mean, there's a wide variety: .NET, Go, Gradle, Java, Node, etc. So let's go ahead and go into, we'll go into Java. So we'll go into CD example. Clearly, the one I did before was Python. We'll go into Java. I'll hit Enter. I'm going to open this up in code real quick so you can see what's actually in it. It's literally a source file. It's a hello world Java. It's super, super simple. I'll make this bigger.
And there is a POM file for Maven.
Yeah, super, super simple, right? So we'll go back over here. I'll go to my iTerm again. I'll zoom in. And now I'm just going to do draft create. It's going to detect Java with 92% accuracy. Let me go back over to my Visual Studio Code, and we'll zoom out. And look at all the files it just added.
Oh.
I have a Docker file right here. I have a charts directory. For those who are new to charts, how I was controlling a lot of the stuff with my Croc Hunter builds and everything, rather than having to go out and write the service ports and container ports and images and all this stuff throughout several YAMLs, I have one YAML. It's called a values YAML. And that values YAML allows me to declare things in one file. And then your templates for your charts will actually parse that in using parameters.
So what do you see here? This big file is actually a Kubernetes deployment file.
Yes.
It's big, it's YAML, and it's kind of painful because everything in it, when you do pure Kubernetes, is hard-coded.
And everything is, you have multiple things, right? This is a deployment, so this is going to take care of my pods. But then my service that expose it is defined in a separate YAML. If I have an ingress handling my load balancing, that's in a separate YAML. And then you can get even crazier with databases and persistent volume claims.
And here Helm helps by providing a templating engine. So you still have all those crazy files, but now at least not everything in them is hard-coded. And you have this values file that will be used for, by the templating engine to populate the values, the real-time values, into those YAML files, and it will take into account stuff like environments. You can have different set of values for your production and for your staging, and you don't have to maintain two sets of those crazy YAML files for Kubernetes. But it's still very overwhelming, and this is where Draft helps.
Yes.
Because Draft will do the default, simple, meaningful thing. It looks at your project. Well, this is Java. It's built with Maven, so we kind of know what to do. We know how the Docker file should look. We know how the Kubernetes YAML files should look. And we can build the Docker file, the Helm chart, and everything which will make sense for a Java project and take all this complexity from you, especially when you start. So tip number 2 for you starting with all that is, tip number 1 was use Azure Kubernetes service. Tip number 2, use Draft. It will draft, hence the name, all this craziness for you, and you will read instead of write. Read instead of write YAML files, which is a whole different experience.
And you also learn the best practices, right? I mentioned earlier talking about setting resource limits and requests, and it already has that baked in. So I'm going to go back over. I don't have to do anything to my draft files. I just wanted to show you. I'm now going to type in draft up, and that's going to, in theory, build my image locally as soon as Docker actually starts. And if not, I'll cut over to my other system here. But it would build my image locally. It would push it into my Kubernetes service locally that I'm using through Docker, and then it actually ends up running out in the cloud. So I'm going to zoom out here. I'm going to quit Docker real quick, and we'll restart it. Cancel this command. While I do that, I'll switch over to the other demo system just so you can see really the value and how powerful it is. We'll go ahead and...
It was half a hint. If Docker stacks, restart it.
So that's the one downside, right? That's the benefit of using the cloud. I'm doing everything locally on my system. If Docker engine or something freezes in the background, which is not unheard of, that happens. So let me CD over. I'm going to get this over here, and then we'll bring it up on the screen.
Yeah, this one works.
Yeah, this one's going to work. I just have to switch it over to bad Wi-Fi here. We'll go ahead and switch this. While that happens, can you explain just a little bit more, I guess, about from a deployment perspective from Draft?
Right. So, well, as we spoke, what actually happens is we take this huge file that was created by Draft, and what you can see here is nothing like really complicated. You have this container which will actually be populated from the chart name and the image registry and everything, and will run it in Kubernetes. And this container is actually produced by this Docker file. And this Docker file, again, doesn't do anything. It will run Maven because we discovered that it's a Java POM file, and will actually run it in, it will use OpenJDK image as a base image, and will just run here the file, the jar file that we produce. So this is the work of Draft that created all this stuff for us. And we have Draft up right there. Should we switch the?
Yeah, I'll switch it.
Right.
It is building, so it's having to download the image right now. Because the Java image is a little bit more larger, it's taking a little bit longer. So I'm actually doing Python in the top corner right now. You can actually see both of them are running simultaneously. So it's releasing my application now locally. As soon as that releases locally, I can do Draft Connect, and I have my application all ready to go.
By the way, you know how to tell that Jessica actually comes from an ops background and I have come from a dev background? She actually had redundancy for their demo. That's unheard of. Usually, seriously, no, that's, yes. Because when I do it, and if the demo doesn't work the night before, I'm like, well, it will probably work on stage.
And there's always that risk, right? So I'll let that go in the background. We only have about 4 more minutes. Oh, there we go. As I said, I'll let it go in the background, and now it finishes. By the way, I'm going to zoom in here real quick so you can see. I'm going to do one more thing. If anybody's interested in my dot files, which is something I am known for online, there's a link to that on his show notes as well. That's one of the most asked questions. But the Python...
and that's actually how the terminal looks so awesome.
Yes, but it does look more awesome when it's not blown up to like 1080 by 720 or whatever this is. So on the right-hand side over here, it built and released my Python image, which is considerably smaller. I'll go over here on the left. I'm going to hit Draft Connect, which now I can see my Java application down below just actually finished. I'm not in my directory, so we'll go back over here, cd example Python. You do have to be in the right directory. That's the first thing.
Ah, come on.
Draft Connect, because it uses a draft file to actually tell you. So I can see right now if I zoom out, I'll bring this up real quick. I need the local host. So here's my local host address. I'll copy that. We'll go over to Google Chrome. I'll paste that right in, and I can see the Hello Ignite application in that left-hand corner.
And this is what the Hello World actually did.
And thanks to redundancy, I'm able to show you that. One more thing I'll show you real quick. There's also public Helm charts if you go to hub.kubeapps.com. They are public charts that you can go to that are ready to use. There's charts like WordPress or Jenkins or JFrog Artifactory.
And that's the benefit of a product that starts with an A.
And that's
right
also
here on the first page.
So you're right there. So I'm going to go ahead and close out of here. We can see the Java application actually, by the way, did just release right down here at the bottom. It just had to build. So I'm going to change back over to JDK8s, which is my Kubernetes cluster. That's my key thing right here. So what I'll do now is...
Sounds like Java development kit, but it's actually Jessica in Kubernetes.
Yeah, it's literally so true. So up at the top here, I'm going to close out of this bottom one so I don't confuse everyone. Up at the top here, I have a Helm install command. I'm naming my install Artifactory Live. I have a Helm repository. I'm going to use JFrogs, which is JFrog Artifactory. I'm going to hit Enter. That's going to go out. It should, that part of the demo is actually over here. Redundancy again.
Right.
So I'm using a secondary repository. I'm using theirs, and I didn't have that added up in here. So we'll go right over here. I type in that command. It actually sets up a full Artifactory instance, and I'll show you what that looks like.
And again, that's like tons of containers working together. You have a couple of Artifactory, you have like a scalable Artifactory Docker container that you have many of them for HA, and you have Nginx, and you have database, and you have what's not. It's all being set up in one command thanks to the Helm chart that, as I mentioned, kind of encapsulates a lot of services into a one actionable chart.
So you can see that here. It deployed out a deployment with Postgres, Nginx. I have a service account. I have roles for rollback, role-based access control security. I have persistent volume claims, so I turn this into a stateful application. I have everything needed for all my pods for Artifactory. I have a stateful set. I have my services, role bindings. I mean, it deployed out all of this. And to show you a live example of what that looks like, I have this screen right over here that I deployed out last night with a full-blown Artifactory instance. I did that in 5 minutes, which is the time it took for them to spin up, but the actual command took me, as everyone saw, 30 seconds. So we'll go back over to the PowerPoint one more time. Last slide I just want to recap on and end. And if you want to come and ask us questions afterwards, totally fine. I just want to be respectful of the next presenters. But some 5 recaps that we talked about for tooling and containers. Build small containers. Application architecture matters, so use namespaces. You might not have seen, but all of my demos were isolated into namespaces for security. I did use Helm charts. That is considered a best practice. Role-based access control is important. I think all current Helm charts today support that and should be embedded in that. It's been a thing since Kubernetes 1.6. Implement health checks. Make sure you're probing your containers, checking that they're alive. Tie in monitoring. Azure actually has monitoring for your Kubernetes. Set requests and limits, as we talked about. Be mindful of your services. I said this in my last session. Map external services, utilize external services when you can, and don't always rely on load balancers. All of my demos, minus the Artifactory one I did, tends to use an ingress controller. I don't have a load balancer for every single application. I route my services either with a load balancer or a service mesh like Istio.
And on top of that, the best practice of starting with Kubernetes is use one of the cloud services and use stuff like Helm and Draft.
Absolutely. And then again, Q&A, we're over time, but come talk to us after. And again, you can follow us online, #MSIgnite. Go to the show notes to get all the content and everything you saw today.
Thank you very much.